All right, you guys, let's have a quick talk about volume. All right. We did discuss surface area before. Let's try and remember surface area is a concept that we're going to be talking about if we want to paint the outside of an object. So we would use surface area to compute how much paint we would want for that project or how much fabric we would want to cover an object. All right. It's a two-dimensional concept. Now, if we take that same object and we want to fill it with water or sand, now we're talking about a three-dimensional idea. It's something that has a length, a width, and a height, some sort of a three-dimensional concept when we move into volume and filling these objects. All right. And so when we're talking about volume of prisms and even cylinders is the exact same concept and conversation. The way I want you to think about volume, all right, is think about here. We have a single two-dimensional square or rectangle, whatever you want to call this. All right. And if I put that object here, it's a two-dimensional idea. Volume is the idea that if I have an object and now I start stacking more of those objects up so that I end up with some sort of a three-dimensional concept. All right. Now this object could be standing straight up and down, which would be more like what we would call a right prism. All right. But even, all right. So the idea is going to be find the area of just one of the bases and then multiply by how many units we have stacked up, which would be a concept called height. All right. And it doesn't even matter. We can even like lean this object over. This would be called an oblique prism. If it's standing straight up and down, it's called a right prism. If it's leaning over, it's called oblique, but it doesn't change. I still have the same amount of stuff here. If I just find the area of one of these bases and then multiply by how many of those I want to stack up, I'm going to get a concept called volume. This works for cylinders as well. I can have just think of this as a single solid circle. And then if I want to stack a bunch of those up, now I can have a cylinder. So if I want the volume, I just need the area of one of these bases and then multiply by a concept called height, which tells me how many of those I have stacked up on top of each other. So our formula then is very basic. We just want to find the area of the base times the height of the prism. So capital B, again, we've seen this letter before. This is the area of whatever the base is. So that has got to change every time. If it's a square, maybe that's base times height or side squared. If it's a regular pentagon, you're going to have to use 1/2 AP. If the base is a triangle, you're going to have to use 1/2 base times height. This has got to adapt every time. H is just going to be whatever the perpendicular height of the prism is. All right, so this is going to work every single time, whether it's prisms or cylinders. So volume, in my opinion, is a bit more straightforward and simplistic concept or idea. The question is, all right, so what are we going to do when that volume? So obviously pyramids, and this next idea will work for cones as well. We don't have that same situation, all right? But when I started to teach here in January of 2000, a long time ago, when I got here, there's only one thing in my classroom. There's this ratty thing here. Now, I believe somebody named Heather Dodd actually made this, but it was in my classroom. And this, in case you tell, is kind of it's a prism. We got a base here, this green shape here. Maybe it's a square. If I want to find the volume, I would multiply by the height of the prism, area of the base times the height. Well, just so happens this object's really cool. There are pyramids hiding in here. Each of those pyramids has the exact same base as this object right here, same base. And each of those pyramids is actually the same height as this original prism as well. The question is, how many of those pyramids are hiding inside here? This would be a great time to pause the video and guess. How many pyramids with that size base, with this height, are hiding inside of here? The answer is, so everybody see now I have two of those pyramids. Both pyramids have the exact same base. And there's actually one over here as well. All three of these pyramids are the exact same. They have the exact same size base and the same height. I can even kind of put it back together, and you can see that each of those pyramids was the same height as that original prism. So if each of those pyramids has the same base and the same height, if I wanted the volume of just that green kid in the middle, then I just need to take the volume of this divided by 3. So our formula ends up becoming the exact same formula here, except I just want 1/3 of the value. If I can make that computation, I am home free, and I can do volume of anything I need. And again, when we start putting things together, because I don't know if you guys remember the surface area problem, if I looked at a cylinder and I wanted to say put that cylinder on top of a prism, this surface area problem is considerably difficult. The volume problem is way easier. It's just volume of the cylinder plus volume of the prism. It's going to work every time. All right. So hope that makes sense for you. I know you guys can all do volume. I'll see you guys in class.